Right, I've decided to make a special video about a certain method of division called the bus stop method, because there are a lot of students who are not comfortable with doing it, or they're unsure. And the more I think about it, it's one of these methods you do need to have in the back of your head in an exam, in case you're asked a question that requires you just to plainly divide numbers together and maybe churn out a decimal as your answer. And there really isn't anything that beats the bus stop method when it comes to churning out a decimal answer. In fact, the bus stop method is also good when it comes to churning out answers with remainders, which has been known to come up on an entry 3 paper. So we'll go through the decimal version and we'll go through getting a remainder version for this video. Right, so origins. Why is it called the bus stop? It's because when you do your answer, you create a diagram like this. I normally curve this, but I noticed some textbooks have a straight line. I don't mind how you do it. I like to do this leg curved. And this is meant to look like a bus stop, i.e. your diddy men would stand here. Oh, he was tall. Waiting for the bus, and this is the roof, and this is the supporting strut that keeps the bus stop from falling on them. That's where it comes from. So now we'll leave that there. So let's now tackle a question. So we could have a question. Let's take an easy one. So we could say, what is 40 divided by 2? So what we do, and you don't argue with this, the 40 goes into the bus stop. The 2 goes outside. So the 2 is in the pouring rain, as it were. He's not going to be sheltered. The 40 gets in the shelter, right? Then we tackle each of these numbers in the 40 one at a time. So we look at the 4. 4 divided by 2, i.e. how many 2's are in 4? The answer is 2. Do we have a remainder? No. So we go straight to the 0. How many 2's are there in 0? The answer is nothing. Is there anything left over? No. The division ends there. You end up with 20 as your answer. We now quote 20 in here. Done. That's a very simple example, but I thought we'll do that first just to get into the swing of it. So let's now take this up a notch. Let's have a remainder. So let's have 35 divided by 3. So we first construct our bus stop, and we put the 35 under the bus stop, and we put the 3 on the outside, and we start again. So we start here, 3 divided by 3. How many 3's are in 3? 1. Do we have any remainder here? No. So we now go to the 5, and we say, well, how many 3's are in 5? This is, well, there's 1. Is there a remainder? Well, yes, because 5 divided by 3 is 1, remainder 2. We've got no more digits here under the bus stop, so we literally just write R2, and then we would quote as our answer. And as I said, on entry 3 papers, I have seen this type of question pop up where they want a remainder, or they want how many things are left over. You would say, well, it's 11, and either you'd say remainder 2, R2. Yeah, that's remainder to you and me. Or you might have to say 11 with, I don't know, if it's sweets divided up between 3 people, with 2 sweets left over. if it actually mentions it's something like sweets, you need to make that specific in your answer. So you might, in fact, let's do this properly. We might say answer is 11 sweets with 2 sweets left over, if we were dividing 35 sweets between 3 people. So that's a remainder version of the problem. So let's now do one where we get a decimal answer, not a remainder. So let's have 44 divided by 5. Actually, let's change that. Let's do 43 divided by 5. Yeah, that'll do. So we construct it again. Put the 5 there. How many 5s are in 4? None. So we put 0. Do we have a remainder? Yes, it's 4. So we put a small 4. In this one, we now have a small 4 here because we've got a remainder part way through the entire question. In the previous one, our remainder ended up at the end with this 5. But we've got a remainder at the beginning. So we put the remainder next to the next number. This number here does not read 3 anymore. This reads 43. How many 5s are there in 43? Well, I know that 8 5s are 40 with 3 left over. So we put 8. Now, I want a decimal answer here. I don't want a remainder. So we've got 3 left over. So what we do now is we've run out of numbers under the bus stop. So we put a decimal point, we put a 0 here, and we then put a decimal point here, and we take the 3 remainder and we stick it next to the 0. So that says 30. How many 5s are in 30? 6. Do we have any more remainders? No. If we did, we would then have to put another 0 and stick our remainder into that and keep going. And if necessary, keep adding more and more zeros as you keep getting remainders. But this one ends here. So you get the answer 08.6. Well, that doesn't look good. So we just write 8.6, and that's your answer there. Right, let me just clean that up. Okay, so let's go. I want to tackle one more type of division that can come up. Let's have something like 3 divided by 1. No, sorry, 1 divided by 3. And let's say you're just told to get this done, but you're not really given any further guidance. So if you weren't given any guidance on this, you need to use some initiative here. If you did 1 divided by 3, how many 3s are in 1? 0. Remainder 1. So we put dot there, 0 there, put a 1 there. How many 3s are in 10? 3. Have we got a remainder? 1, because 3 3s are 9, and I wanted 10, so I got a remainder of 1. So we make another 0, we put a 1 down. How many 3s are in 10? 3. Do we have a remainder? Yes. 3 3s are 9. That's not 10. We have a remainder of 1. Now, you will start getting an awful pattern of loads of 10s along the bottom here and loads of 3s at the top, and it will carry on forever and ever and ever. If you see this pattern starting to occur, this is called a recurring decimal. So at this point, you go back here and you can write 0. What's the number that keeps repeating? It's a 3 along the top. 3, and you put a dot here. that tells the examiner that you believe that this number will repeat forever and ever and ever. It will just have a long line of 3s. In fact, if you do 1 divided by 3 on your calculator, depending on the calculator, you might be shown this figure, or an older calculator will just show 0.33333 and it will fill your whole screen. If, however, you see something like this, the sensible choice, if the examiner didn't demand a decimal, would just be to write this. 1 divided by 3 and leave it at that. You've converted it into a fraction because that line means divide. And that is all you need to know about the bus stop method. What I would advise you do for those who struggle with this is to just keep replaying this video over and over again. Do some examples. In fact, what I would do is I would make up a question like, I don't know, 100 divided by 5. I would check my answer on a calculator first. Then I would do the bus stop method on that question and see if I can make it match the calculator, and just keep plugging away at it until the bus stop method becomes natural.